So there's a lot more to the study of language that we haven't got to here. And just to list some of the topics, we could say a lot more about language in the brain, how neurons and neural systems encode. Related to this, we could look at language disorders. We can study reading. And reading is interesting because reading, of course, involves language. But unlike language in the sense we've been talking about it so far, reading is not universal. It's a relatively recent human invention, and it's difficult. We can study bilingualism and multilingualism. A lot of people in the world have more than one language in their heads, and how that all works is a fascinating topic. And then there's three other topics, and I want to spend just a little bit talking about each one of them. We've now characterized language with some degree of precision. We talked about phonology, morphology, syntax. We talked about the stages in which it's learned. And we can now ask, do other animals possess the same sort of language? Do they possess language in the sense of English and Chinese and Russian and so on? And this is maybe the most controversial part of this lecture because people have wildly different views. But my own sense, and I think I'm capturing the sense of the field here, is that the answer is no. Other creatures have rich communication systems, fascinating communication systems, but they're different from the human communication system. You have animals that have a finite list of calls, like vervet monkeys will have a call for a snake or an animal that's attacking. You have animals that use a continuous analog signal, like bees. And then you have random variations on the theme, as in birdsong. But what you don't find is phonology, morphology, syntax, arbitrary names, recursive syntax, and so on. And there's been some arguments that maybe in some special cases you find something that looks like this. But certainly if you were to look in an objective fashion at the capacities of non-humans, you would never say, wow, that's language in the same sense that what we're doing now is language. It seems very different. Now, there have been a lot of attempts to teach non-humans, particularly non-human primates like chimpanzees, language, and there was a lot of enthusiasm about this many, many years ago. But the consensus by now is that these attempts have not succeeded. These animals can develop a limited vocabulary, but it takes a long time to learn the words. It's very different from children. Very limited ordering and no recursion. And you also get highly repetitious speech. These are some samples from an animal, Nim Chimpsky. You could get the reference of the name, who's been taught to use a form of sign language. And these are the sorts of things that Nim Chimpsky says. Nim, eat, drink, eat me, nim, give orange, me, give, eat orange, me, eat orange. One could wonder theoretically, why would you even expect a chimpanzee to learn human language? We don't expect human babies to learn how to dance like bees, sing like birds, or hoot like vervet monkeys. I think a theory more grounded in evolution would predict that each animal would have its own evolved communication system, and it's sort of strange to expect one animal to learn the communication system of another. A further topic is language processing, and I'm just going to restrict myself to mentioning one issue and giving one demonstration. The issue is, how much does your knowledge of language and your expectation of language influence your perception of it? And we actually spoke about this before when we talked about word segmentation. So as I'm talking, you hear gaps between the words. But the gaps aren't really there. You hear the gaps because your understanding of how English works and what English words are leads you to perceive them. But I'll give you another example here of how your knowledge of what somebody's going to say, what somebody said, will influence how comprehensible their speech is. So to illustrate this, listen to this. Now, if you're hearing this for the first time, you probably have no idea what that person just said. So this is what they said.
The steady drip is worse than a drenching rain.
And now I'll play you back the original sound. The steady drip is worse than a drenching rain. And that's all I'm going to say about language processing. The topic I'll end with, and I will spend more time on this because I find it incredibly cool and connects to some of my own work, is something which people often raise when we talk about language, And this is the relationship between language and thought. So plainly, language can be used to convey our thoughts. I think something, I use my language to express it. And plainly, language can influence thoughts. You may not have had any opinion about Freud, but if you listen to me talk about him for a little while, maybe this will change your views. But that's all obvious. Here's the cool question. Does the language you learn change the way you think? Do speakers of languages like English think differently than speakers of languages like Korean, by dint of differences in the grammatical structure of the languages? So I choose this example because it's been studied quite a bit. English and Korean have different prepositional systems. English uses prepositions like in and on and under, while Korean uses a different set of prepositions that focus you more on things like whether something is firmly attached to something else. And so a lot of psychologists have studied children and adults, wondering whether exposure to these different languages changes the way you think about the world. Does being exposed to a language, as another example, that has a special plural marker for two-ness. So in English, it's either dog or dogs, one dog or many dogs. But in other languages, you could have one dog, another marker for two dogs, and then something meaning more than two dogs. Does this make a difference for how we think about number? And there's a lot of very exciting research on that. That's the one question. The second question is a more general one. Is language necessary for abstract thought? So think about all the things that are uniquely human. We have logic, we have rich mathematics, complicated social structures, cultural learning, extraordinary technology. And humans also have language. Maybe the fact that we have all these cognitive abilities plus these linguistic abilities are not two separate accomplishments, but one goes hand in hand with the other. So this was a speculation by Charles Darwin. Darwin wrote, "If it be maintained that certain powers, such as self-consciousness, abstraction, and so on, are particular to man, it may well be that these are the incidental results of other highly advanced intellectual faculties, and these again are mainly the results of the continued use of a highly developed language. Language has cascading effects that makes us smarter." And more recently, the philosopher Dan Dennett, "Perhaps the kind of mind you get when you add language to it is so different from the kind of mind that you have without language that calling them both minds is a mistake." So is this true? Well, there's an extraordinary amount of debate about it. My comments about animals and their lack of a human-like language are controversial, but this stuff gets really controversial, and people have different views. And I'll give you sort of a warning that what's going to follow is my perspective. But my perspective is this. There are a lot of studies looking at false belief tasks. The Sally-Ann task, which involve inferring that other people have knowledge of the world that's false. And this is a fairly late developmental accomplishment, and it's impaired in autism, and it's difficult. Maybe you need to have sophisticated language to understand that others can have false beliefs. I think the evidence here is against this. So for one thing, using very subtle tests, even 15-month-olds can pass the false belief test. And even people with severe aphasia or damage to the parts of the brain that do language can solve false belief tasks. So it might be that reasoning about other minds is not dependent on language. That's one part of the story. But here's the second part of the story, which is number. And here I think the evidence for the power of language is pretty clear. So I'll quote Stan Dehen, who's one of the world's leading scholars in the study of number, who writes, "Without symbols, we may not discriminate 8 from 9. But with the help of our elaborate numerical notations, that is language, we can express thoughts as precise as the speed is 299 million meters per second. Without language, we couldn't just express the thoughts," Dehen would argue, "we can't even think them." Well, why would we take this seriously? One reason is a certain distinction we find between non-linguistic creatures, like babies and dogs and chimpanzees, and linguistic creatures like us. It turns out that these other creatures are capable of some rudimentary mathematical reasoning. Even babies know that 2 plus 2 equals 4 and 3 minus 1 equals 2. We saw this research earlier on in this course. And they know that a big number plus a big number equals another big number. But here's what babies don't know, and here's what chimpanzees don't know. They don't know precise numerical relationships. They don't know, for instance, that 8 plus 8 equals 16. And it might be, in order to understand that 8 plus 8 equals 16, you need a symbol system that allows you to reason about these specific high numbers. That is, a creature without language could never come to such a conclusion. So I'll end the lecture on language with a rather complicated conclusion, and it's not surprising it's complicated. We're complicated creatures, and the complicated conclusion is that language may be essential for some unique human powers, but not others.